transition time, we're going to actually fast forward to lesson 2-8 because 2-5, we're going to go over in our next chapter actually with absolute value and inequalities because I think it fits in that section more. And 2-6 and 7 are going to be our next lesson, okay? So this is, I think, really related to what we were doing before with variables on both sides of the equation. And now we are going to solve equation by isolating a specific variable and manipulating formulas to solve real-world problems, okay? Because before, like we were kind of adding, subtracting on both sides of the equation, multiplying, dividing on both sides of the equation. We're going to do the same thing. Now talking about wanting to just find a specific variable, right, when I have a bunch of variables in my equation. So let's look at an example to get a better idea. Here is the Common Core standards, right, vocabulary. These type of problems are called literal equations, right, because I have multiple variables that I can manipulate, and those variables mean something, right, like base times height, right, and area, and all that stuff when we're looking at formulas. So let's look at this one kind of as a little starter, okay? I want to solve 5b plus 2c equals 9 for b. I want to isolate the variable to get b by itself, right? So I want to figure out what is this equation going to look like when I get b equals what, okay? So what will be equal? Here's that. Okay? So now let's write it out. I got 5b plus 12c equals 9. Alright, and it looks like I can't really combine like terms on this because they're not the same variable. So I'm going to move to doing order of operations using SAD/MEP. Okay, I'm going to try to find the variable b by itself. So what I need to do is get rid of this 12c over here. How can I do that? Alright, remember I can use SAD/MEP and add or subtract on both sides of the equation even when I have a term with a variable on it. Alright, so I can subtract 12c on both sides like this. Okay, then let's see what happens. I'm going to draw that line down the middle. Alright, so this cancels out. And I'm going to be left with 5b over here. And just because you write 9 minus 12c, you might be thinking, hey, Mr. Tran, those aren't like terms. We can't subtract them. Yeah, that's true. So we'll just write it out and not subtract them, right? Because 9 doesn't have a c variable. So I'll write 9 minus 12c and just leave it just like that. Alright, just showing me that I can subtract, but I'm just not combining like terms. So now I got addition and subtraction, okay, out of the way when it comes to b, so I got that checked out. Now let's look at division and multiplication. Right now, 5 is being multiplied by b. I'm going to do the inverse operation of multiplication, so I'm going to divide by 5 on both sides, okay? So 5 times divided by 5 is going to cancel out. Give me 1, and that's going to give me b equals 9 minus 12c over 5, okay? And now is b by itself? Okay, yes it is. So b is equal to 9 minus 12c divided by 5. Okay, do you guys see how I have this variable by itself? Okay, I just shuffled some of the terms around to get that variable b by itself. Okay, so that's how you do that type of problem. And let's look at now a word problem and why this might be useful when we're solving and manipulating formulas and variables around. Okay, you're looking at fuel economy. Alright, a car's fuel economy, E, miles per gallon, is given by the formula E equals M over G, right? Where M is equal to is the number of miles driven and G is the number of gallons of fuel used. Solve the formula for M. Alright, so I want to get the M by itself. Right? What does that look like when I manipulate the variables in this formula right here? Okay, so my OG, okay, my OG formula is equals m over g. Okay, I want to get this m by itself, right? He just wants to be a loner and be a loner. I don't know. Okay, so as we see here, it's m divided by g. So remember that this g right here is just like any other number, right? It's just that you can plug any number in and it will just determine the value for the field economy E. So it's like a number. So it has the same property number. I can add, subtract, multiply, divide with this number. And what do I want to do to cancel out this g in the denominator to get m by itself? Okay, if I want to cancel out in division, I'm going to have to multiply, because the multiplication is the inverse of division. Okay, so once again, I'm doing SATmath. Okay, I don't have any addition subtraction, so I'm jumping onto division and multiplication. So I'm multiplying g over here and also g over here, because we're doing one side, do the other side, and these are going to cancel out like that. Okay, so what I end up getting is g times capital E equals m. And since it's all by itself, this is what I get. Okay, that's my basic formula when I find m by itself. So now, how is this useful? All right, let's look at this. Okay, so let's see what happens if Quanna's car has an average fuel consumption of 30 miles per gallon and she used 9.5 gallons. How far did she drive? Okay, so let's kind of define the variables. When I was talking about miles per gallon, I'm talking about fuel economy, how much I use in gallons over miles. So that's the giant E, and that I'm going to say is 30. Okay, now what was the variable for G? Okay, that is the number of gallons, and the gallons is 9.5 gallons. Okay, traveled. So if I want to find out how far she's driving, what I'm missing is that M. Okay, what is that? How many miles do I have? Right, so before I had my equation E equals the miles driven per gallon, and I manipulated the variables to have gallons times E equals M from my previous problem. So all I'm doing, folks, is that I'm just getting this value. I'm going to plug it in where G is right here. And we get this guy. And he's going to plug in where capital E is right there. So if I write everything out, I get 9.5 times 30. It's going to equal the number of my miles driven. And that's going to give me 285 miles. Okay, for my value of M. And that should be correcto. Okay? So, quick little application of how to play around with variables. And you're going to use this a lot in algebra, where you're going to have to kind of find a variable by itself. Okay, by kind of shuffling some terms around. Alright? So, go for it. Try your best for these practice problems.